peeps, today we're going to talk about osmotic pressure, which is often in the chapter on colligative properties. So if you look at my diagram over here on the left, I'll explain what osmotic pressure is. I have a beaker, and in the first beaker you can see there is what is called a semi-permeable membrane, meaning that small particles like water molecules can move back and forth across that membrane. Also in the solution, you can see we have these pink spheres, which represent sugar molecules. You can see that on the left here, there is only one sugar molecule per all those water molecules. And on the right, we have 4 sugar molecules for a few of the water molecules. What's going to happen is osmosis. We're going to have the water molecules move from the left portion of the membrane to the right portion of the membrane until the ratio of sugar molecules to water molecules are equal. In other words, we achieve an equilibrium. So in beaker number 2, you can see here that the level of water or solution has gone down because we've had water molecules going over to the right side of the membrane so that the ratio or concentration of sugar to water is equal on both sides. We see this in the human body. So over here on the right, I have a picture of blood cells. And so we have in the center what's called isotonic. Isotonic is when the 2 solutions on either side of the membrane, and so the membrane is going to be what encircles the blood cell here and separates the solution inside the cell from the solution outside the cell. When the 2 solutions are the same, it's considered isotonic. Now, when we have a non-equilibrium between the solutions inside and outside the cell, we form other conditions. The next condition is what we call hypotonic. Hypotonic, the fluid has a lower concentration than the cell. So if we look here, remember, the membrane is only going to allow small particles to go through. So water is actually going to go into the cell. The cell is going to swell in size until the concentration outside the cell is equal to inside the cell. So you can see in this picture here that the blood cells are a little puffy. And that's because they've had water come into them so that the concentration is the same on the inside as it is the outside. Over here, hypertonic, the fluid has a higher concentration than the cell. And so what's going to happen is the water is going to flow out of the cell to outside the cell until the solutions are equal on both sides. So down here we have it blown up. So if you look here, hypotonic, the water that's inside the cell is going to come out until the proportion of the solutes to the liquid water is equal. And so you can see up here that the cell gets all shriveled up because it loses its water. Here in the middle, isotonic, they're equal on both sides of the membrane. And here, hypertonic, you can see there's more water molecules outside than inside, so they're going to flow into the cell and swell them up. Okay, so when we're talking about osmotic pressure, we actually have a formula. And this symbol here almost looks like a pie. I know it doesn't really look like a pie on my screen, but that pie symbol measures the osmotic pressure in a solution, okay? And it is equal to the Van Hoff factor, I, times molarity, times R, which is the constant from the gas laws. And in the examples I will do following this video, I'm going to use the constant 0.082 atmosphere liters per mole K. So it's a constant, and we used it in the gas laws, and we're going to use it here also. And then temperature is always in K, in Kelvin. So you can see here I've defined it down below, but I will do some examples in the videos that come next. You can find me on TikTok and YouTube at Chem's Chem Chats. Leave me a like or a comment, and I'll see you on the next video.